this is our space test chamber. This is a big vacuum chamber that we put our instruments and spacecraft into to test them, to prove that they're going to work in the vacuum of space, to prove that they're going to work in the temperatures, the cold temperature of space, and with the appropriate sunlight coming in and hitting them on one side but not on the other. So we can simulate all of that in this big chamber. So we can fit fairly large spacecraft or instruments into here all at once and test them as we go. It's a monster of a door because it has to withstand the pressure of the atmosphere pushing onto it. When the chamber's at vacuum, if you imagine sucking the air out of a Coke bottle or something similar, it just crushes down. So this has got to be able to withstand that sort of pressure, but with absolutely zero air inside. Okay, as you can see, there's a door on either end of this chamber, and the door at the far end is also open. This morning we've just taken a spacecraft that's been in test in this chamber out, pushed that through the other end and out the clean room at the other end of the chamber, so we've actually got access from both sides. So inside the chamber we've got these two main rails. This is what we mount spacecraft or instruments on. There's also a series of sky hooks, rails on the ceiling. We can suspend spacecraft from there, hang them down so that there's no real contact between the item that we're testing and the chamber walls. Okay, so these panels that surround the whole test chamber and coat the insides of the doors are the cooled shrouds that we simulate the cold of space. To cool them down, we pump liquid nitrogen through them. So we have a massive liquid nitrogen tank outside that we can push nitrogen through all of these panels, cool them right down to 77 Kelvin or so at any one time. They've also got a heater on the back. So if we want to simulate a hot environment, if we're testing an instrument that sits inside of a spacecraft, we can also heat these up and take them up to any temperature that we want to as well. One thing that isn't installed and wasn't used for this last test is a solar simulator that we have. This is a big wall of lights that simulates the heat input from the sun to a spacecraft that's in spacecraft orbiting the Earth. So we can pump light onto it, prove that the solar cells work, and to prove that the thermal control systems work on the spacecraft. Okay, well the first thing that happens is that we remove all of the air. In behind the shrouds mounted on the chamber wall, massive pumps. These pump all of the air out the chamber, so we get it down so that there's a pressure of what's called about 1 × 10⁻⁶ millibar. That's a factor of 1 billion less pressure than the standard atmospheric pressure on Earth. So there is still gas particles in here, but very few. It's a good simulation of the space environment. The next thing that we do then is, in the case of a cold space-type test, we would cool some or all of the shroud panels down. We can control in different zones and control each panel separately. So inside here it would be cold, it would be dark, and it would be no atmosphere. So there's no way a person could survive in here without a spacesuit for very long. It's a very good simulation in terms of temperatures and pressures. Of course, we can't get rid of the gravity. If we could do that, I'd have patented that and made my millions long ago. So instead, to test for zero gravity, you have to do other types of tests where you would, for example, test something in one orientation, turn it over, test it the other way up. If it works in both of those, it's likely to work in zero, unless there are some certain cases with fluid loops and things where you have to do a better simulation of zero G, but that's as good as we can get. The length of tests that we run can vary enormously. Sometimes, like the one we've just done on a full spacecraft, that's taken us about 10 days. That was a fairly standard, simple test to run. We just did a couple of thermal cases and proved that it was all going to be okay. For some of our more detailed scientific type instruments, they can take much longer. For example, we've got a test happening next year that's going to be running for about 90 days. So roughly 3 months where we'll have to be working 24/7. So the people that use this facility, either we do internal work, so things that are being built here at the lab and being tested, we have access to these facilities, but also we provide this enormous test facility that's much too large for almost any individual company in the country to use. So it's nationally funded, so anyone can come in, pay to hire the facility without having to pay the enormous expense of building one themselves.